Okay, so today we are in section 1.1 in our book, and our learning objective is you will be able to graph equations, making tables and plotting points. Okay, so first thing is we need to talk about this word solution. The solution is the value, so aka a number, or values that make an equation true. Okay, so in other words, we could have the equation x minus 4 equals 5. So the question is, what is the x value that makes this true? In Algebra 1, you learn that to get rid of subtracting 4, you add 4 to both sides. So therefore, your solution is x equals 9, because 5 plus 4 is 9. Okay? We could also get equations like this. Okay, and then we could ask something like, if the x value is 1, what's our solution? In other words, what's the negative 1 point on this line? So I could take negative 1, put it where x is. So 3 times negative 1 plus 2y equals 7. So negative 3 plus 2y equals 7. 2y equals 10. Therefore, y equals 5. So the point on my line at negative 1 ends up at negative 1, 5. Okay, so you could have one variable, you could have two variables. So, examples. Determine if the given points are solutions to the equation 2x squared plus 5y equals y. Well, I know this is my x value, this is my y value, so I can plug it in. So, 2 times negative 1 squared plus 5 equals 7. Okay, well, this we can calculate. So negative 1 squared is positive 1. So this becomes 2 times 1 plus 5. 2 times 1 is 2, plus 5 is 7. So 7 equals 7. Yes, that is true. So therefore, negative 1, 7 is a solution. In other words, negative 1, 7 is a point on this parabola. How do I know this is a parabola? I know it's a parabola because it has an x squared in it. Okay, so it's our U-shaped graph. Okay, I'm going to ask you to pause the video and go ahead and try B and C and determine if B and C are solutions or not solutions. Okay, you should get the answer 0, negative 6 is not a solution. But 0 or 5 comma 55 is a solution. Okay. Okay, so we're going to ask you to represent in this class many different types of equations. We're going to ask you to represent lines and parabolas and a couple others that we'll learn throughout the year. Remember, every equation can be represented in multiple ways. You could make a table of the information. Okay, you could make it an equation. You could take that equation and make it into a graph. You could even model it, such as making a word problem or a picture. And all of these methods can go back and forth. So you can move from one to the other all the way around. Okay? One thing I want to make sure you make note of here is make sure that when you're using your graphing calculator, in other words, when you're graphing with the calculator, okay, the only way your calculator will graph something is if it's in y equals. So you always need to put equation into y equals form. Okay, if it's not in y equals, then move things around the equal sign before you plug it into the graphing calculator. Okay, so now we are practicing going from a table to a graph. So we want to make a table of information. Okay, we don't know what shape this graph is. The only thing we know is for sure it's not a line. This is not in y equals mx plus b, so therefore it is not a line. You couldn't put it in y equals mx plus b. It's x cubed. Okay, so we are to the point now that we can go ahead and use our graphing calculators. So we hit y equals, clear anything out that's there. All you have to do is press clear. And you're going to enter this in. So 7 minus the X button is right under the word mode. So X, and then to make a little 3, we use what we call the caret 3 and hit enter. Okay, so let's look at our graph. So if I hit the word graph, there is your graph of that equation. If your window doesn't look like mine, hit zoom, go down to zoom standard. This is like your home screen. Hit enter, and now you should be back and your graph should look like this. So it's kind of like a squiggly, a downhill squiggly. Okay, we want to make a table. So see this word table in blue? Okay, let's go hit it and hit second table. And there, now instead of us creating our own table, it's created for us. And I'm just going to choose some values that would fit. So I'm going to start at -1. So I'm going to copy the table straight from my screen over on my paper. So -1, 8, 0, 7, 1, 6, 2, -1. And I'm not going to copy any of the other ones down because then they get too big and they're not going to fit. And now I can graph them. So -1 of 8. 1, 2, 3, 4, 5, 6, 7, 8. Put a point. 0, 7, 1, 6. Oops, sorry. 1, 6. And 2, -1. Now, go back to my graph and make sure I connect the points to make this kind of curvy shape. So it's going to come down and go to this point, and then squiggle down and go down this way. Add your arrows because it goes on forever, and you're done. Okay? This guy does not say y equals. So the first thing I'm going to do is I'm going to move this +3 over to this side. So, and I move a positive over, it becomes a negative. So now I'm plugging into my calculator y equals the square root of x minus 2 minus 3. Notice this -3 is not in the square root sign. It's outside of the square root sign. So y equals, clear out what I have. I need the square root sign. The square root sign is under, or it's sorry, it's above the x squared and it's blue. So second square root, x minus 2. Now, I can't have this -3 under the square root sign, so I arrow out that stops the square root sign, and then -3, and I graph it. Okay, notice my graph stops. Why does my graph stop at the left-hand side? What kind of numbers can we never square root? Okay, that needs to be your thought process. There are certain numbers we can't square root, so there's a reason why our graph stops here. Let's go to our table. So second table, Notice there's a bunch of errors here. That's because these x's don't work. If I plug 1 in here, 1 minus 2 is -1. I can't square root negative numbers. Okay, so I'm going to start here at 2, -3. I make my table. X, Y. 2, -3. 3, -2. Notice I have decimals. Decimals are fine. I'm just going to go until I get to a nice number. 6, -1. And then 11 is not going to fit, but if I need it, I can do 11, 0. Now I graph my points. So 2, -3, 3, -2, and 4, 5, 6, -1. Okay, go to my graph to make sure I connect them, and I'm connecting them with a curve. Okay, both of these graph shapes you saw in algebra, you saw square root graphs. They were curves. They were U's on their side. You saw cube graphs. They were squigglies. That's at least what my freshmen called that graph. Okay, last thing that we need to talk about today is our intercepts. Okay, our intercepts are a point or points where the graph intersects an axis. Okay, there are two intercepts. You have your x-intercepts. These are where the graph crosses the x-axis. In other words, we have a y equals 0. Our point value would be like a number comma 0. The second type of intercept we have is we have our y-intercept. That's where the graph crosses the y-axis. This means our x value is 0. And if we were to look at the point, it would be 0 comma some number. So you would have a number here, you would have a y number, but 0 in the x value. You would have an x number, but 0 in the y value. Okay? So, approximate all intercepts using your graphing calculator, then find algebraically. So you have to do it two ways. You use your graphing calculator and you do it by hand. Okay, you won't have to do that every time, but in this case we are. So I do notice that this is a y equals mx plus b. That you should recognize right away. We should also know that b is our y-intercept. I know without even plugging anything into my graphing calculator that my y-intercept is at 0 comma -1. That's my y-intercept in y equals mx plus b. Now in this one, it's not the same because this is not in y equals mx plus b. Take out my graphing calculator, hit y equals, clear out that line. Okay, calculator. When you plug a fraction in your calculator, it's a division problem with parentheses around it. So parentheses 2 divided by 3, close the parentheses. X minus 1. Hit the word graph. There is my fantastic line. And I can see that my line hits at -1, which is what we wanted. So I'm turning the screen down a little bit. Okay, it hits it at -1, which was our y-intercept. That's what we were expecting. Okay, if I need to find an x-intercept, I hit this word trace. it makes a little bubble, a little blinking X, and you can trace, you can drag left and right, and at the bottom here, it tells you your points. The only thing that you can do here is you can figure out approximately where it is. In other words, my x-intercept is between 1 and 2, okay? And if I look down here, I get 1.66 repeating, aka 1 and 2/3 at 0.11, which 0.11 is pretty close to 0. Okay, this is farther from 0. Oh, this one is even closer to 0. 0.01 is closer to 0 than 0.11. So I'm going to choose this one. So approximately my x-intercept is at 1.51, comma, 0. I understand that this is not perfect 0, but we are getting approximate. We are getting really close to 0. Now it says I have to find them algebraically. Remember, your x-intercept is when y is 0. Your y-intercept is when x is 0. I'm going to take out the y and I'm going to put 0 in its spot. So 0 equals 2/3 x minus 1. Solve it for x. So 1 equals 2/3 x. I divide by 2/3. Dividing by 2/3 is the same as multiplying by 3/2. Okay, 3/2 times 1 is 3/2. 3/2 is 1.5. Look at my approximation. My approximation is 1.5. My actual calculation is 1.5. So my x-intercept is at 1.5, comma 0. This was using my calculator. This bottom is algebraic. My y-intercept is by plugging in 0 for x. So y equals 2/3 0 minus 1. Anything times 0 and 0. 0 minus 1 is -1. Y equals -1. So my y-intercept is at 0, -1, which is exactly what we got here. We're doing the same thing to this guy. We don't know the shape of this graph. This is not anything. We're going to say that it could look like a parabola. That's probably a good guess because it has squared in it. But we don't know for sure. So 4 over x squared plus 1. So I go to my y equals, clear out what I need, hit clear. Now, on this guy, be careful. We need 4 divided by, in parentheses, don't forget your x button is here, x squared plus 1. If people are having trouble putting things into their calculator and you're finding buttons and they're not seeing them, please help them. So we hit our graph. Ooh, that one's an ugly one. Ugly. So my y-intercept is pretty easy. My y-intercept, I would say, oops, hold on, my intercept, is at 0, comma, 1, 2, 3, 4. Okay, that one's pretty easy. Can see that one. My x-intercepts, though, I don't see it. So I'm going to go to my table because I can check my table. And if I look at my table, my numbers get always closer to 0, but they never hit 0. I never get any negative numbers here. What does that tell me about my x-intercept if I never go from positive to negative? If I don't go from a positive number to a negative number, then I don't have any x-intercepts at all because I don't hit 0. So we're going to say, according to our graph, there are no x-intercepts. Now let's check our calculations. Now we're going to use our algebra skills. My x-intercept is when y equals 0. So I take 0, I change y to 0, equals 4 divided by x squared plus 1. How do I make a fraction into 0? The only way for me to make a fraction into 0 is by doing 0 divided by something. You can't ever put 0 on the bottom of a fraction. 0 divided by, can I change this 4 to a 0? I can't. You can't do anything with this. There's nothing you can do here. So this one, you can't go any further. This is as far as you can go. So therefore, there are no x-intercepts. Even if you tried to put this over 1 and cross multiply, 0 times this is going to be 0. Let's go ahead and find our y-intercept. So our y-intercept is when x is 0. So 4 divided by 0 squared plus 1. Y is equal to 4 over 1. 4 over 1 is just 4. So my y-intercept is at 0, 4. Okay, what you're going to do now is you're going to go onto Canvas under Assignment Guide, click on Chapter 1, and then you're going to click on Day 1, the first assignment, and it will, or look at the first line, first assignment, it will tell you what homework problems to do. Have a great day.